Hi everyone, this video is a continuation of the videos on electricity I have already done. Please do watch them before learning this, okay? In this video, I'll be explaining 5 points which will help you to solve any numericals in electricity, okay? So let's start. So first one, when you have resistances in series, the current coming out from the cell flows out through each resistance and then it comes out back. You find that current through each resistance will be same. Current through each one is same because when it reaches here, it finds only a single path to flow. There is only a single path for the current to pass. So, the I over here will pass through R1, comes out, then pass through R2, and then it will pass through R3 and then come out. So, you can say I through R1 is same as I through R2 is equal to I through R3. So, when resistances are in series, current through each resistor is same because it finds only a single path to pass through. Is that clear? The next point is what happens when they are in parallel. When resistances are connected in parallel, current flowing out from the cell, when it reaches the point A, it gets divided itself in different arms. A part of the current will flow through R1, the other part will flow through R2, and when they reach B, they combine together and give back the same value over here. Is it clear? The current flowing through the resistance depends upon the resistance. So you can say I is inversely proportional to R. I value is inversely proportional to R. If the resistance is high, current through that resistance will be less. Because when you say resistance is high, you can remember more obstructions. Therefore, less current flows through that. If R1 is less than R2, then current flowing through R1 will be greater than current flowing through R2. Is that clear? So it is inversely proportional. And remember, it gets added up here at the point B. Now, the next point is about the potential difference. When you have the resistances in series and when you connect voltmeter across each resistor, you find that PD across each resistor is different. It depends upon R. And potential difference is directly proportional to R. If R value is greater, V value also will be greater. It is directly proportional. Remember, PD across each resistance is different when they are in series. And another important point you got to remember is when you add up the PD across R1, R2 and R3, that is V1, V2 and V3, when you add them up, you find that that value sum is equal to the terminal voltage here. The sum is equal to the terminal voltage. Is that clear? So you can say the PD across each resistor is directly proportional to R. And the next point is when the resistances are in parallel, PD across them is same. These two resistances R1 and R2 are connected between A and B. And when they are in parallel, this is the way you show. And voltmeter is also connected across the points A and B. So this value PD across the resistance over here is actually showing the PD for these two combined, because you have taken the connection from the same points. So PD across R1 is same as PD across R2. That is what you are going to remember here. Okay. So you can say the PD across each resistor is same when connected in parallel. Is that clear? And the last point what I want to tell you is, we are going to use the formula V is equal to IR to solve any numerical problems in electricity. You can do with this formula. This is the only formula you have to learn. So solving numericals we'll do in the next video. Okay.